between this curve f and g, we see that sometimes f is above g, sometimes g is above f. So to find this area between the two curves, we will use this absolute value over here. So that area is going to correspond to the integral of the absolute value of f of x minus g of x, where x goes from a to d. Okay. Now in this particular example, when you expand this, that will be equal to the integral of f minus g, where x goes from a to b. And when x goes from b to c, g is above, f is below. So that will be g minus f over here. And this last part from c to d, f is above, g is below. So that will be f minus g. Now look at this example 4. We're trying to find the area of the region bounded by this curve y equals sine x, y equal to cosine x, x equal to 0, and x equal to power 2. Now first observe that sine x and cosine x intersect when x equal to power 4. Now if you don't recall that, you can actually find this out by solving this two equation together. So y equal to cosine x and y equal to sine x, then sine x will be equal to cosine x. Now we're trying to solve for this x here on 0 to power 2. Then you can divide both sides by cosine x. So sine x over cosine x equal to 1. So tangent x will be equal to 1. So x will be equal to power 4 on 0 to power 2. So the corresponding x value here is power 4. So the area of the region over here, the highlighted region over here, is equal to the integral of the absolute value of sine x minus cosine x. Now from 0 to power 4, cosine x is above, sine x is below. So that will corresponding to this integral cosine x minus sine x, x go from 0 to power 4. And from power 4 to power 2, sine x is above and cosine x is below. So that will be sine x minus cosine x, x go from power 4 to power 2. So we break this integral into two separate parts. Depends on which function is above, which function is below. Now, for antiderivative cosine x, it is sine x. Antiderivative of negative sine x is cosine x. Antiderivative sine x is negative cosine x. Antiderivative of negative cosine x here is negative sine x. So we substitute power 4 and 0 in. And here we substitute power 2 and power 4 in. So substitute power 4, we got this. Substitute 0, we got this. Substitute power 2, we got this. Substitute power 4, we got this. Now, when you simplify this, we got 2 square root of 2 minus 2. Now, notice that in this particular example, we could have saved some work by noticing the region is actually, this two region is actually symmetric about this 9 x equal to power 4. So these two regions are symmetric. So if I can calculate A1, I can double that to find this area, the total area over here. So the total area is 2 times A1, which is 2 times this integral over here. That will save you some work. Okay. Right, so let's take a break.